VC Chemistry, Unit 4, Digestion of Fat and Oils. So before we start, I'm going to pause here for a while and ask you to think about what's the irony of this animation here. It's an avocado running. Okay. Most people who does cardio these days want to lose fat. And avocado, hint hint, is full of, although healthy, but fat, right? So it's literally living the slogan of wanna lose fat, gonna lose yourself first. Oh ha ha ha. Right. So digestion of fats and oils. So fats and oils are insoluble in water, and therefore they remain intact until they reach the small intestine. Okay? And bile, which is produced by liver and stored in your gallbladder, enters the duodenum and emulsifies fat globule. Okay. What does it mean emulsify? It basically breaks down the entire big chunk of fat into small fat droplet. Okay, fat droplet. Just imagine the idea. Okay. Now my question is, why do we need bile to break the fat globule into a fat droplet? Well, hydrolysis of fat requires lipase, and lipase is an enzyme. It is a water-soluble enzyme, so it can only interact with the fat globule, which is hydrophobic, on its surface. And therefore, the larger the surface area, the higher the rate of hydrolysis. So that's why bile breaks it down. It basically says it emulsifies the fat so as to increase the surface area of the fats, and therefore allowing lipase to actually access that fat droplet more effectively. Okay? So when the amount of fat and carbohydrates eaten is more than required to meet the body's energy needs, then triglycerides are formed and stored in adipose tissue. That's basically fatty tissue. And it's stored as energy reserve. Okay. So with fats, we need to talk about something called oxidative rancidity. So rancidity means that it's a notable deterioration in taste or smell. So basically, food goes off. It's called rancidity. Okay? So oxidative rancidity refers to breaking down of fats and oils into harmful short-chain ketones and aldehydes. And we know that ketones and aldehydes actually are poisonous, right? But that's why sometimes you eat some like meat or chicken that's off, like it smells off. It actually makes you sick because you are eating ketones and aldehydes and makes you sick. Okay. It normally happens between oxygen and unsaturated fatty acid chains of triglycerides. So basically, the healthier the fat, the more likely it's going to be oxidized, and therefore it's more likely to go off. Okay? So the higher degree of unsaturation, the more susceptible it is to oxidation, and therefore more likely it's going to go off. Food with high percentage of unsaturated fat should be stored in refrigerator. Like, for example, a little like fish is full of omega-3 and omega-6. That's why fish should always be stored in refrigerator, like right away, in low temperature, so as to reduce the rate of oxidation. Okay, so the process of oxidation, we call it auto-oxidation. What happens is that under sunlight and the UV light, the oxygen will attack the carbon-carbon double bond, breaking that double bond into a charged particle and a free radical. So what are free radicals? Free radicals are basically an entire molecule or a group of atoms with A1, like unpaired electrons. They are free radicals. And we call them radical because they're very, very unstable and they're highly reactive. So the free radicals can go on, then attack other part of the hydrocarbon chain to break them and oxidize them, and therefore it's making it really susceptible into turning into aldehydes or ketones. Right? So The carbon-carbon double bond are susceptible to the attack of oxygen in the air, especially under UV light. That's why a lot of times when we store food, when we try to prevent it from going off, we want to store it in the shade, okay, away from sunshine. Okay. So to prevent this, the auto-oxidation process, antioxidants or sometimes preservatives are added to prevent or slow down the process. Okay? So antioxidants, as well as preservatives, they're basically strong reductants. They sacrifice themselves by being oxidized in preference to the food they're protecting. So reduces free radicals can delay oxidation of substance, but since we can't really reduce free radicals in a normal environment, we're normally using antioxidants to do that. What they do is, as we said, they are reducing agents, so they are oxidized in preference to what they're protecting. So a lot of vitamins like vitamin A, vitamin C, vitamin E, they're really good preservatives for our body. Not really real preservatives. We call them antioxidants. So they're good for our body. Right? So most of them, how do they work is that they work by donating hydrogen to peroxides. So where does peroxide come from? It comes from the process of auto-oxidation that we talked before. So we said that in auto-oxidation, initially it was oxygen plus UV light. It attacks the carbon-carbon double bond and make the hydrocarbon chains into a group of atoms with an unpaired electron, which is free radicals, right? And then it's actually a chain reaction. We don't need to know the specific steps, but in those chain reactions, they always produce, or there's one step that produces peroxides. And we know that peroxides are very, very strong oxidants, right? So the antioxidants, what do? Is that they donate hydrogen to peroxides so that the peroxides no longer react with nearby molecules. They don't go around to oxidize the nearby molecules, and therefore basically stops the auto-oxidation process. Okay? And I just want to ask you to remind you that in organic chemistry, donating hydrogen, losing hydrogen means oxidation. So the antioxidants, they are the reducing agents who donate hydrogen and goes through oxidation. Okay. A lot of those hydrogens donated are from hydroxyl groups. That's why vitamin C is such a great antioxidant. Preservatives, so basically they are artificial antioxidants as opposed to vitamin A, vitamin E, vitamin C, which are natural antioxidants. So preservatives work in a similar way, but they have to be limited to prevent from harming human body. And also at the same time, since preservatives, they only delay oxidation because they are sacrificing themselves to be oxidized in preference, right? Once they go out, food will still be oxidized as a result. So even with preservatives, food still has limited shelf life. Okay? For us human beings, a diet rich in a variety of colors is more likely to contain natural antioxidants.